Hi guys, so this is going to be a video on getting the relative atomic mass from a mass spectrum. Okay, and so a mass spectrum just shows you the relative intensities of isotopes for a given element. And so right here we have bromine, and we have the relative intensities given for each of the isotopes of bromine. Here we have bromine 79, so 79 bromine. Right here we have bromine 80. Here we have bromine 81, and here we have bromine 82. Okay? And so looking at those isotopes, now we can kind of see roughly where the relative atomic mass is going to be, right? Since 79 and 81 make up most of the intensities, right? They have the biggest intensities. It's probably going to fall somewhere in between 79 and 81. So that just kind of gives us an intuition for how much the relative atomic mass is going to be. Of course, we can calculate it exactly by using the formula, right? The relative atomic mass, AR, is equal to the sum over all of the isotopes of the fraction times the atomic mass of the isotopes, right? So we have to calculate the fraction. So for bromine 79, right, the fraction for that is going to be, well, it's relative atomic mass, right? So 1100, it's relative intensity, 1100, divided by the total intensity across all of the isotopes. And so the total intensity would be 1100, so right, total intensity is going to equal 1100 plus 100 plus 1100 plus 70. Okay? The reason why we need the total intensity is because the fraction of the isotopes that are of here, right, that's going to be the relative intensity of that isotope. So relative intensity of isotope, and then it's going to be divided by the total intensity. It's the fraction of all of that sample that is of that isotope, right? So the total intensity, 1100 plus 100, that's 1200 plus 1100, 2300 plus 70 is equal to 2370, right? You can, of course, use a calculator for that. I just kind of did it in my head real quick, right? So we have 1100 divided by 2370. All right, so that is the fraction for bromine 79. The fraction for bromine 80 is 100, its relative intensity, divided by the total. So 100 divided by 2370. For bromine 81, it's 1100 divided by 2370. And then for bromine 82, it's 70 divided by 2370. Okay? And so now we're trying to add up the fraction times the atomic mass. And so we have 4 different isotopes, meaning we have 4 different terms here to add up. Okay, so for bromine 79, that's going to be, well, we have the relative fraction, right? The relative fraction, so that's 1100 divided by 2370 times, this is bromine 79, so its atomic mass is 79, right? Plus, well, we have bromine 80 now, so 100 divided by 2370 times 80, plus 1100 over 2370 times 81, right? That's the fraction for bromine 81 times its atomic mass, and finally 70 divided by 2370 times 82. Okay? All right, and so now we just have to do a little bit of math, right? And so I'm going to pull out my calculator. I'm going to quickly do this, right? So we have 1100 divided by 2370 times 79 plus 100 divided by 2370 times 80, all right, plus 1100 divided by 2370 times 81 plus 70 divided by 2370 times 82. Okay? And so the math turns out to be 80.05 atomic mass units. Okay? Atomic mass units. And so that's how you calculate the relative atomic mass for bromine. Okay? If you were to look this up, right, if on the periodic table, you should find that the value is pretty close to the relative atomic mass that you find on the periodic table. Of course, people are going to be using much more accurate data, much more accurate methods to get their relative atomic mass, so maybe it's going to be slightly different, right? If I compare this, 79.904, right? Maybe there's other isotopes that we don't know about. Yeah, there are a number of different reasons, but, right, the same basic process applies, right? You find the relative fraction for each isotope, and so that's going to be the intensity divided by the total intensity. And then you multiply that by its atomic mass, and then you sum it all together. Okay? Hopefully that helps. Good luck studying, guys.